Hello everyone and welcome back to Clear Creek Solutions hydrology education videos. Today we're going to be getting into water characteristics and quality and some of the basic facets and terms that we're going to be discovering when we start to learn about water characteristics and quality. So that's what's going to be covered in this video here. We have many other hydrology education videos in our playlist that you can find on our YouTube channel. Anyways, what is an introduction to this topic? Well, if we think of pure water, it's a tasteless, colorless, and odorless liquid made up of hydrogen and oxygen with a chemical formula of, many know, it's H2O, right? Because water is an almost universal solvent, most natural as well as man-made substances are soluble in it to some extent. And consequently, water in nature contains dissolved substances. In addition, as a result of the hydrologic cycle, it contains various other substances as well as sometimes even gases. So we don't find pure water in our natural environment that often, right? It always is going to have some sort of solvent or other particles in it. And that's really what makes it water. And it's sort of dissecting what is in the water that we start to get into the topic of water quality. These substances are often identified as the impurities found in water. So the principal impurities found in water and their origins are listed in a table that I'm going to show later. The impurities are classified as 1, ionic and dissolved, 2, non-ionic and undissolved, and then 3, gases. Dissolved impurities are further classified to 2 groups, depending on whether the ions are positive or negative. Non-ionic and undissolved impurities are often categorized according to size and are identified as suspended if they will settle and colloidal if they will not settle. So color and organic matter can be classified as both ionic and dissolved, as well as non-ionic and undissolved, depending on the nature of the molecules. For example, humates are ionic and dissolved, whereas tannins are non-ionic and undissolved. In the evaluation of water quality, the impurities in the water are usually classified as physical, chemical, and biological. Thus, according to the table that I'm going to show you, bacteria that are colloidal, non-ionic, and undissolved impurities will be considered biological characteristics with respect to water quality. Water is to be used as a public water supply. The physical, chemical, and biological impurities that may be present are also referred to as contaminants. The presence or absence of impurities depends on the source of that water. So for example, suspended matter is commonly found in surface water, but it would not be expected in groundwater because of the filtering action of the aquifer. So when we have water travel through a groundwater system, what the soil does is it actually naturally filtrates many of the solids out of the water, and so it ends up actually being cleaner than sort of suspended water that we can find on the surface. And to evaluate whether the specific impurities reported in the table are harmful, one must determine 1, the nature and amounts of the impurities present, 2, the uses to be made of the water, and 3, the tolerance for various impurities for each use. So not all water is used the same. You can sometimes have more impurities in a water if it's used for a different use as opposed to drinking water, for instance. So let's talk about sampling. The collection of water samples to be used in determining the impurities that may be present is an important step that is often poorly conceived. First, the sample must be representative of the source that is to be evaluated. Second, the sampling equipment, procedures, and techniques must be selected so that changes in the constituents to be analyzed will not occur between the time the samples are collected to the time they're analyzed. And so thus, if dissolved gases are to be determined, file analysis may be necessary. Special care is also required when bacteriologic samples are to be determined. So let's talk about the units, and that's really where this is going to start to get complicated here, as when it comes to water quality, the units is going to be very particular. So the unit most commonly used to define the concentration of impurities found in water is milligrams per liter, which is also equals to grams per cubic meter. Concentration can also be expressed as parts per million on a weight basis, and the interrelationship of these units is as follows. Parts per million equals milligrams per liter divided by the specific gravity of liquid. If you want to learn about specific gravity, go find some of our earlier lessons on our channel. So what's some additional definitions here? This is going to be really important when it comes to water quality treatment. So the number of moles, mole, equals weight in grams divided by the weight of the 1 mole, or grams per mole. And then moles of a gas equals the volume of gas at STP in liters, and the volume of 1 mole of gas at STP. And STP stands for standard temperature and pressure. Equivalent weight, grams per equivalent, equals an atomic molecular weight in grams divided by Z. And the grams per equivalent, G over equivalent, equals milligrams per milliequivalent. So now that we've got some of those terms there, we can start to get into more of the details. So here's a table of the impurities of water. So you can see there's 6 categories here, or 7 categories here on the left. We have turbidity, hardness, chloride, fluorides, oxygen, nitrates, and suspended solids. And the defects in the beverage could be a variety. For turbidity, it's haziness in the end product. For hardness, it's scaling in the pipelines or the equipment, and then also an off taste to the product. Chloride is a production of off flavors and augments the corrosive nature of the water. Fluorides can cause damage to teeth enamel. The oxygen corrodes the water pipelines and equipments. Nitrates may cause blue baby syndrome in small children, and suspended solids, it can cause deposition in the pipelines or the equipment. So what's some of the treatment we can use to get rid of turbidity? Well, there's filtration, coagulation, a settlement tank. For hardness, we can use water softening or addition of surface active agents. For chloride, we can use demineralization or reverse osmosis. For fluorides, a similar process. Oxygen, we can use deaeration. For nitrates, we can use demineralization or reverse osmosis. And then for suspended solids, we use a combination of filtration, coagulation, and settlement tanks. So what's some additional physical characteristics of water? Often the result of chemical analysis are reported in terms of calcium carbonate, which is CaCO3. This is a very common used metric. This conversion is done by multiplying the weight of a constituent expressed in milliequivalents per liter by the milliequivalent weight of CaCO3, which is 50 milligrams per milliequivalent. The principal physical characteristics of water are 1. Total suspended and dissolved solids, 2. Turbidity, 3. Color, 4. Tastes and odors, and 5. Temperature. Total solids are determined by evaporating a sample of water. The difference between the total solids and suspended solids represents the dissolved solids. So what are some additional physical characteristics? Well, depending on the size of the openings in the filter paper that is used, a portion of the colloidal material will also be measured as suspended solids. Information on total suspended solids is used for design of water treatment facilities, and the total dissolved solids concentration, in conjunction with a detailed chemical analysis, is used to assess the suitability of various water sources for alternative uses such as industry or agriculture. So that's a quick basic review of water quality. We have a hydrology terms guide, which you can find in the description box down below. It's 100% free. It's got about 4 pages of hydrology terms guides used in the industry, or maybe you're studying for an exam, maybe your PE exam regarding water resources or water quality. So you can check that out there. I hope this video was informative. And anyways, we will see you guys next time.